Have you ever looked at a towering skyscraper and wondered if there might be a better way to design our buildings? Welcome to a fascinating exploration of biomimetic architecture, where nature becomes our greatest teacher in designing the buildings of tomorrow. Imagine structures that don't just look beautiful, but actually function like living organisms, adapting to their environment and solving problems just as nature has done for millions of years. In the next half hour, we'll discover how architects and engineers are revolutionizing building design by learning from the most successful designer of all time, Mother Nature herself. The term biomimicry comes from the Greek words bios, meaning life, and mimesis, meaning to imitate, and it's exactly what it sounds like, the practice of learning from and emulating nature's genius. This concept was popularized by Janine Benyus in her groundbreaking 1997 book, Biomimicry: Innovation Inspired by Nature, which suggested we look at nature as our model, measure, and mentor. But why should we look to nature for architectural inspiration? Think about it. Living beings have spent billions of years evolving solutions to complex problems through trial and error, developing incredibly efficient ways to survive and thrive on Earth. In our modern world, where energy efficiency and sustainability are crucial challenges, these natural solutions might hold the key to creating better, more sustainable buildings. Let's start by taking a journey through time to understand how this fascinating field developed. The relationship between architecture and nature isn't new. In fact, it dates back to ancient civilizations. The ancient Greeks and Romans drew inspiration from trees when designing their iconic columns, while Byzantine artists incorporated stylized versions of the acanthus plant into their designs. One of the most famous early examples of biomimetic architecture is Antoni Gaudi's Sagrada Familia Church in Barcelona, begun in 1882, where he used tree-like branching columns to support the massive vault. But modern biomimetic architecture goes far beyond merely copying nature's appearances. It's about understanding and applying nature's problem-solving strategies. Today's architects and engineers study everything from termite mounds to lotus leaves to create buildings that are more efficient, sustainable, and harmonious with their environment. There are three distinct levels of biomimicry in architecture: organism level, behavior level, and ecosystem level. At the organism level, architects directly mimic specific features of individual organisms. A perfect example of this is London's famous Gherkin Tower, designed by Norman Foster, which mimics the structure of the Venus flower basket sponge to create a building that's both strong and energy efficient. The building's hexagonal skin helps distribute stress loads, just like the sponge's lattice-like exoskeleton does underwater. Moving to the behavior level, architects study how organisms interact with their environment and apply these principles to their designs. The Eastgate Center in Harare, Zimbabwe, is a masterpiece of behavior-level biomimicry. This shopping complex stays cool without air conditioning by mimicking how African termites maintain consistent temperatures in their mounds through clever ventilation systems. The building saves an astounding 90% of the energy that would be required by a conventional building of the same size. At the ecosystem level, architects look at how entire natural systems work together to create balanced, sustainable environments. The Sahara Forest Project is an ambitious example of ecosystem-level biomimicry, creating a self-sustaining greenhouse system inspired by the Namibian desert beetle's water collection abilities. The project combines multiple natural strategies to create a closed-loop system that produces its own water and energy while growing food in the desert. But biomimetic architecture isn't just about copying nature's forms, it's about understanding the principles behind them. Let's explore how architects use the biomimicry spiral, a 6-step process developed by Carl Heistrich to create bio-inspired structures. The process begins with identifying the core function needed, then translating that into biological terms to find natural solutions. After discovering relevant natural models, architects abstract the key principles and adapt them to human needs. The Qatar cacti building shows this process in action, taking inspiration from how cacti survive in desert environments. Its windows feature smart shades that open and close in response to heat, mimicking how cacti regulate their water loss through transpiration. One of the most exciting aspects of biomimetic architecture is its potential to solve our current environmental challenges. Consider the Eden Project in Cornwall, England, with its geodesic domes inspired by soap bubbles and pollen grains. These massive structures are incredibly strong yet lightweight, using minimal materials to create maximum space, just as nature does. The field is also revolutionizing urban planning, as seen in the proposed city of Lavasa, India. This entire city is designed to handle monsoon flooding by mimicking how local plants and animals have adapted to these conditions over millions of years. The city's rooftops are modeled after banyan fig leaves, complete with natural drainage systems, while its water management strategy is inspired by local harvester ants. However, biomimetic architecture isn't without its critics. Some argue that it creates an artificial separation between humans and nature, while others worry it might limit innovation by assuming nature's solutions are always superior. But proponents counter that biomimicry actually brings humans and nature closer together, creating a harmonious blend of natural wisdom and human innovation. The future of biomimetic architecture looks incredibly promising, with new technologies making it easier than ever to study and apply nature's solutions. Advanced computing and 3D printing are allowing architects to create increasingly sophisticated designs that were previously impossible to build. Perhaps most importantly, biomimetic architecture offers hope for creating a more sustainable built environment. By learning from systems that have evolved over millions of years, we can design buildings that use less energy, create less waste, and work in harmony with their surroundings. The principles of biomimicry teach us that the best solutions often already exist in nature. We just need to learn how to see them. From the way a beetle collects water in the desert to how a termite mound stays cool, nature's innovations are all around us, waiting to be discovered and applied. As we face growing environmental challenges, biomimetic architecture offers a pathway to creating buildings that don't just take from nature, but learn from and work with it. The buildings of tomorrow might not just look different, they might actually behave more like living things, adapting to their environment and operating as part of a larger ecosystem. By embracing these principles, we're not just creating better buildings, we're reimagining our relationship with the natural world. As we conclude our exploration of biomimetic architecture, consider how your own built environment might be transformed by these principles. The next time you see a building, try to imagine how it might function if it took its cues from nature. You might be surprised by the possibilities. Remember, every challenge we face in architecture has probably already been solved somewhere in nature. We just need to look, learn, and adapt. Thank you for joining me on this journey through the fascinating world of biomimetic architecture, where nature's genius shapes the future of our built environment. Please like and subscribe for more videos like this. Be sure to leave a comment on what topic you'd like to see next.